Okay, in this video we're going to compute the variance and standard deviation of a discrete uniform distribution. So I am going to assume that x has a uniform distribution on the set of positive integers up to some number n. Okay. And remember that means that the probability that x is any certain one of those integers is 1 over n, so long as k is in that set. And we saw in a previous video that the expectation of x is n plus 1 over 2. So if I want to compute the variance, what do? Well, I have the expectation of x minus mu squared. What that means is I plug in all my possible values for x, multiply these by the probabilities, and then add them up. So we'll be summing over all the possible values, which is from 1 to n, of k minus n plus 1 over 2. Mu means the same thing as the expectation, times the probability that x is k. So that would be times 1 over n in this case. Okay, now this is a little of a messy sum, so we're going to have to evaluate it using Wolfram alpha. Let me pull that up. Okay, so I'm summing k minus n plus 1 over 2 squared times the probability that x is k, which is 1 over n. I'll just divide by n, and I'm going from k equals 1 to n. And we press enter, and Wolfram alpha simplifies this down to 1/12 times n squared minus 1. So when we go back to the blackboard, we'll see that this is just n squared minus 1 over 12. Okay, and that is the variance. For the standard deviation, then I take the square root of the top and the bottom. So I'll just write that as the square root of the fraction for n squared minus 1 over 12. Okay, now in the video in which I computed this expectation for a uniform distribution, I also considered the situation in which x is a random variable between two numbers whose difference is an integer. Let me draw a line to show that I'm really dealing with a different situation here. Okay, well in this case, when we're talking about a measure of variation like variance or standard deviation, it doesn't really matter what this first value is. It just matters how spread out they are. Okay, so we might as well put this first value as 1, and the only value that matters is n, how many there are. So for this case, n is the number of elements in the set, and that is b minus a plus 1. So we'd have b minus a plus 1 squared minus 1 over 12 for the variance, and then the square root of that for the standard deviation. You will not need to know that. I'm not going to use it in this course. I just thought for completeness that I would throw it in here. Okay, but these are the ones that are going to be important that will show up again, that we will need to know.